Hybrid Cloud Show, Episode 15. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. So today I've got a question for you. Do you ever consider the environmental aspects of your cloud computing, or do you just like to watch the world burn?
How dramatic. Wow. I would say yes. I mean, I try to keep everything as efficient as possible, so I'm not wasting resources. So I try. But then again, I'm sure my Kubernetes node is deployed in some sort of multi-tenant fashion, and the person who's also on my node is probably not doing the best. But with what I have control in, I try to. But don't ask me about my home lab, please.
I was going to say, now cut the crap. Remind me how much power that rack next to you is drawing.
Presumably you have a solar panel sitting on the roof that makes that one go, right?
I would love that. I actually got quotes for it, and it was way too expensive. So not yet. But yeah, it's an obscene amount, and it's totally overkill. I'm working on reducing it, but I have to get the wife approval first.
I think you step on an interesting point about this, which is electricity's a cost-benefit analysis, and it's cheaper to throw more energy at something sometimes than pay engineers to optimize things. So it's an uncomfortable trade-off, I think, we make a lot of the time. And we might come at this from a spend perspective, but maybe it's also an environmental one we don't think about.
Yeah, I mean, at this point, I've powered down my home lab to consuming 50 watts or less, according to the thing on the front of the UPS, if that's ever to be trusted. So it's fairly good, but like you say, Shane, I've also probably spent money on new equipment or have handed equipment down to my home lab, let's say, in order to get to that point. So have I spent money to save money? Yes. Is there also an environmental impact of me moving my old Mac Mini out to the garage to have a nice ARM virtualization node and then replacing it with a new Mac? Yes, absolutely. There is an environmental impact of doing that. On the flip side, the box that I have running in OVH is an Ivy Bridge Xeon. So that has not been replaced in a really long time, consumes lots of power, but equally the environmental cost of manufacturing new hardware is pretty much zero because that machine's been in service for 12 years, I guess, at this point.
So is it better to buy new hardware and run at more efficient, or to use what you already have and continue life as long as possible?
Depends if I'm paying the power bill. I mean, for me at home, I was spending £20 a month on running the equipment that I used to run in the garage, whereas now it's probably a tenth of that. It's a really, really small, pared down set of hardware. So for me, that was worth it. And my house runs on entirely renewable energy, if you believe what the energy provider says, and they're doing all of the right carbon offsetting and everything else. So that probably was worth it if I keep that equipment around for long enough.
It is definitely something I think about when I'm doing my home stuff. I was looking at the Nano KVM and comparing that to the Pi KVM. And, there is a difference there in terms of the power consumption of doing one of those little things instead of having a big system, running. And whenever I'm looking at a box that's going to sit there on 24/7, then I will look at the power consumption of that to try and think, what makes sense. That's where I think these Wise boxes everyone keeps talking about on our shows are so good, that the power consumption is low compared to a lot of the other servers you would have running.
The cute thing about this is we're talking about our home labs where the upper limit of forests on fire is quite low. I was considering this question more from we could probably, scale down these 200 EC2 instances running some PHP app, but we don't understand why the bottlenecks are happening at 4:00 on a Wednesday. So let's just leave it there. It's all good. I think that was the scale of issue I was thinking about when I was thinking about this problem.
Yeah, I mean, that's reasonable to go there. I think I think if we're going to solve the environment's problems, it's probably not starting from my home lab. But that is the next step. And I think it's interesting that we've all talked about trading off things like the costs of the hardware, the environmental cost, and the electricity cost. And those things are all different factors that come into a cost, right? And how that reflects the environment is a little bit incidental, unfortunately, for a lot of people who are making decisions. I think it's important, but even more the case when you get into business, does it become a money question?
Well, I almost think it's kind of the opposite, right? So in my home lab, my concerns are mostly driven by, one, power bill, and two, having something that's quiet and small and appeases my wife and stays out of the way, which is why it runs on top of a cupboard in the garage. For work stuff, generally, with the three big cloud providers, the newer, more efficient instances are the same price, but they have a better power to performance or power to amount of compute ratio. If I were to move from a T2 instance on Amazon to a T3 to a T4 Graviton instance, the Graviton instance is pretty much the same price, sometimes cheaper than the Intel or AMD instances, but has better performance and is better for the environment because they can cram more of those things into the same power envelope. So it's almost the opposite question, isn't it? It's, do you do the engineering work to move the thing to a newer instance or compile it for a different CPU architecture? Because the cost is slightly cheaper for the newer, more efficient hardware, and you probably need less of the same machines.
ARM is a really good point here, I think. And I think when Azure launched its ARM instances, they said something like 40% better price compute or something. And so you were talking a pretty significant jump in what you could get for the same money, and it would reduce your power. So how much have you seen in practice people moving to ARM for those savings or those benefits?
I think when you've abstracted away a lot of the server management stuff to things like Lambda, it's kind of trivially easy. Like for example, if I've got Node running on a Lambda, unless there's some particularly interesting dependencies in there, it should be quite a trivial swap over. So just for the savings, it almost could be a line or two config change and you're up and running with a cheaper, faster bit of hardware, but your mileage may vary. That's an idealized scenario. So it really depends.
For something like a database as well, it makes a bunch of sense, right? If you've got a managed Postgres and all you care about is a connection string and what kind of disk IOPS you're getting, then there's a very easy sell there to move that to ARM. But like you say, Shane, the 40% number that Azure threw out, for example, is going to be for some very specific set of workloads they tested on or averaged out. And in reality, you might see 5%, you might see 50%. It's hard to tell without testing it. I guess the thing is, though, that if it is that much more sustainable in terms of power use or your bill or whatever else, maybe you recognize those trade-offs quite quickly, even if you don't quite realize the 40% claim.
Even when you go down the layers, even if you're not doing Lambdas and Node and those sort of high-level things, a huge proportion of the Ubuntu archive runs on something like ARM. So if you're in that Linux ecosystem where you are using packages out of the archive, there's a very good chance that what you need is going to be available for ARM, just like it is for x86.
That's a big if, though, right? If you've got some massive monolithic application that you're packaging up as a container, and you have some places where you might need to run that on x86, and some places you might need to run that on ARM, you could, in certain circumstances, be doubling the cost of your build farm, or doubling the energy consumption or whatever it is of the build farm, in order to then save a little bit on the back end when that's then running on an ARM instance in certain regions or certain use cases. So it is really difficult, I think, to put a number on it. You know, it's all very well saying, yeah, you get 40% better price to performance or whatever it is. But that's assuming, like you said, that you're just taking the instance as is and running something on it. And that's really not always the case. In fact, most of the time you do have some bespoke internal application you're running, I would wager.
Well, then let's talk about the elephant in the room. CI/CD, guys. How often are you guys running your builds? Because with my team, we're running base images. I think it's every day. And then application deployments happen frequently, multiple times a day. That's a lot of CI/CD to go through there. And I can advocate as much as I can to say, maybe we don't need daily updates of our base images. Maybe weekly is sufficient to cover our security concerns. But then the application security guys are like, no, you should do that as often as you can. And they're not really concerned about that. So where's the middle?
Well, I think it's like I said in the previous episode, you take that set of what if we do, what if we don't, to leadership and say, hey, we can rebuild our base image every day. The trade-off is that we're going to burn this much CO2 or it's going to cost us this much. Whereas if we bake a new image every week, then all right, we open ourselves up to 6 days potentially of some 0 day being out there, but we're going to save X amount of dollars or X amount of CO2. So I think it's a really interesting question to ask, because you ask 4 different CTOs, you're going to get 4 different answers as to what their priorities are. Some people are going to be way more security minded. Some people are going to be way more cost minded. Some people are going to be way more sustainability minded.
It's the classic economics problem, though, isn't it? That you want your externalities to be properly priced into the pieces so that you can make a good assessment of your costs and benefits. If you are looking at it and you can price all of the environmental impact into the price that you're paying, and then you sit there and make a decision of that price versus the benefits, then it becomes a much easier problem. It's a bit more challenging when you price some of that in, but not the other downsides of trashing the planet.
I guess it's also pretty hard as a developer to do this on your own. You'd probably need more information that you wouldn't have access to kind of be able to estimate those numbers.
I think we mentioned this in a previous episode, but I still want the VS Code plugin that has, like, if you're writing like a Terraform file and like you change the amount of compute and then there's like, I don't know, squirrels burning or something, and you've added more compute, there's more squirrels burning. There's some sort of very quick feedback for like, I'm killing the seals or something. I don't know. If we're going to go down like environmental impact, like we need some faster feedback probably. It kind of leans into another question I had around this topic, which is like, is cost a good proxy for environmental impact? Like, could we have replaced, do you consider the environmental impact, but do you consider the cost impact? And would that have had the same actual outcomes?
No, I don't think it is a good proxy, because it depends on where you're running the workload, right? I could run a workload for $2 a month somewhere, but it's sitting in some data center that's got a coal-fired power station next to it, right? Whereas I might pay $20 a month for that same workload running in a cloud provider that is got renewable energy or is doing carbon offsetting or something like that, where, all right, it costs more, but the environmental impact of that is way less, at which point it then does become a financial decision of, am I willing to spend 10 times as much in order to know that that workload with a reasonable degree of confidence is running somewhere much greener? So I think it is a proxy. And certainly if you were comparing apples to apples, like you're looking at running an instance in a given region and all things are equal, maybe cost is a proxy for that. But I don't think it is the only thing that you have to take into account.
I guess that's a really interesting topic. Like, I was kind of thinking within a cloud provider, you've already got established, but maybe for bang for your buck, like a good way to evaluate this is to think about your cloud provider itself before you make that decision. Like, how do you know your cloud provider isn't powered by burning coal every day?
Well, even within a given cloud provider, there could be differences, right? It's way easier to get green energy in Western Europe than it is in the Middle East, for example. So running the same instance in Dubai versus London might have really, really different environmental impacts, even though the dollar per hour cost is pretty much the same.
Yeah, this is an area that's incredibly complicated. I think there's all of these sort of different ways people report on things like offsetting and whether the offsets are close to where they're causing the environmental impact, or whether it's a long way away, or whether your traded offsets are coming from particular countries and things like that. I have a memory of there being something way back when where you could buy EFTs that effectively originated from the reduction in size of the USSR or something of that ilk. And so there were cheap EFTs that you could buy based on effectively a resizing of a country. And so that I don't think, all offsets are created equal. And I would love it if we were in a place where you could do that, but the world isn't governed by one government. So all of it's these sort of bilateral or multilateral agreements between countries, and they're not perfect. So it's very, very hard to capture those environmental externalities into a system that's translating into dollars in a good way.
And equally, reporting on this stuff at scale is probably really hard. Like, how can I, as an end user, know that some managed service using an equivalent amount of compute is better or worse than running that thing myself on EC2? It must be really, really difficult to work this stuff out, just for you, let alone at the scale of tens of millions of end customers for the cloud providers. And I know they've all got tooling which reports on this, but it's going to have varying degrees of accuracy, would be my guess.
What about things like compiling your code versus not compiling your code? Using something like Go or Rust or whatever, as opposed to using something like Python in your code. Is that something that we think has a measurable enough impact in the way that these workloads are running that it would have an environmental impact of note?
I think it's very small. I think it almost comes down to the same conversation as my home lab consuming 200 watts versus 50 watts. Sure, I could probably save some compute cycles by pre-compiling stuff with the right flags for a given CPU architecture, but I just don't think that unless you're running at the scale of some hyperscale huge company, it's going to make a measurable impact given the millions of tons of CO2 that we know are being emitted every day. It's almost like me saying, I get the train to work, and that makes me more righteous than you driving your car to work. I mean, sure, it does, but in the grand scale of the millions of people who go to work every day, is it making a huge difference? Or is someone spinning up a new coal-fired power station actually the problem? It's a really difficult thing to measure.
I think some of that goes back to the question Sean was asking around the testing and CI/CD and those sorts of pieces, because if that has a good function, if that CI/CD is actually stopping you introducing bugs into your code and then not meaning that you've got a whole bunch of people who are doing a whole bunch of work to find those bugs later because they were in the CI/CD and so they were found straight away and then they were reverted or whatever, then it's really hard to balance the sort of pros and cons of that. I think that's completely different to getting rid of waste. And that's why I sort of liked that ARM example, because if you've got a workload that runs just as well with less power in the same data center by the same provider, you can swap one in and replace the other and get a benefit for the environment and maybe for cost. If you've got some waste where you are running tests that have nothing to do with the thing that you're changing, maybe that's something that you could do that doesn't impact things. But if it's something that's got a real use, it's really hard to trade those things off.
Your mention of waste there made me think of another thing. A lot of cloud providers have these instances that are effectively the spare capacity on other servers. So in AWS, the spot instances, right? So you then have to sort of ask, well, am I doing a better job of reducing the CO2 footprint of the workload by utilizing that unused capacity on boxes that would otherwise be sitting there churning away? I guess we have to assume that cloud providers aren't using things like P states and C states in a lot of cases to downclock CPUs for idle workloads, because that's going to affect the other customer workloads that are running on the box. So maybe there is an argument there to be said that actually the first thing you should do, rather than re-architecting the thing or recompiling it for ARM, is maybe seeing if you could deal with the interruptions of something like a spot instance, because you're then using hardware that would otherwise be sitting there burning away.
I agree with that to a point. I think that spare capacity is spare within boundaries. So you build your data center, it gets used to a certain point, you build more capacity. And so I think if everyone went and used the spare capacity of a cloud provider, they would build more capacity. And so I don't think you could look at it and say, oh, that's truly free from an environmental perspective. But I agree with you that as everything stands at the moment, using that spare capacity is a better idea than going and turning something new on.
Well, I guess the calculation you make there is that there is lots of different types of spare capacity, right? There is spare capacity on T instances and M instances and C instances and whatever else. And most workloads don't suit using that spare capacity and can't deal with the, oh, by the way, we're going to take this away from you in 20 minutes because now a full paying customer wants it. So if you can architect your workload such that you can use any one of those 10 different instance types for spare capacity, and you make the assumption that most workloads won't be able to do that, but yours can because it's some static website or it's backing off to a data store somewhere, and actually you can cope with 20% of the pods being interrupted and being spun up somewhere else within that 20-minute interruption window. I think it's fairly feasible to run large parts of your workload in that way. And if you can, then that's probably quite a good thing to do.
Yes, and I think compared to going and putting something in your own data center, that can often be the same kind of question. If it's something you're only going to use occasionally, then renting that from the cloud probably is an environmental benefit rather than having new hardware that's been created and sitting there largely idle in your data center. I've seen that with some of the ARM stuff again, where people have got ARM-specific workloads and they only need a relatively small amount of ARM for whatever they're doing. Then that can be sensible to run in the clouds as opposed to buying specific ARM servers for that.
I guess the other thing is cloud providers have these economies of scale when they're building out data centers, and they can do things like water cooling with rainwater and stuff that maybe you wouldn't be able to do if you built a data center yourself. If I think back to the last, I don't want to call it a data center, but the last company server room that I had to put together, we didn't have a huge amount of budget, and we certainly weren't going to do things like water cooling with rainwater or 100% renewable energy or whatever, because we were in a warehouse in an industrial estate, and we ended up with 4 racks with a wall-mounted air conditioner in front of each one, blowing 16 degrees centigrade cold air into them. That clearly is not as sustainable as a really professional data center. So it'd be interesting to get your guys' thoughts on, is there a way that you could build your own on-prem stuff in a more efficient way? Or is it just a case of Amazon or Google do this all the time and have the ability to go and do those things in a much better way than you ever could?
There's on-prem and there's on-prem, isn't there? I mean, I'm usually very, very skeptical when someone says they want to run something in their actual office, unless it's something very, very specific to their office. Most of the time, if someone says they want to run something on-prem, I would hope that they're at least running that in a professional data center.
Yeah, I mean, the cloud providers have economies of scale, so I'll never be able to justify tweaking something to reduce the wattage of a couple of servers in a data center. But for a big player like Azure, AWS, this could mean millions in savings. So I have to imagine that they have tweaked and optimized. I mean, even Spot Instances as a product we've discussed, like just trying to get as much capacity use as possible versus potentially idling servers that are dedicated to me. I think inherently using the cloud, you're going to struggle to match probably the cost and environmental impact work that they've put in.
And even stuff that as a company you might put in a quote unquote professional data center or co-locate. It's a smaller scale, and it might be an older data center or a data center that's in a location that doesn't lend itself to renewable energy or passive cooling or whatever else. I've worked in places before where we co-load stuff in what at the time it was built was a state-of-the-art data center. But 20 years on, there are real advances in data center technology that we're just not in a position to take advantage of unless we pick up all of our servers and drive them to some other colo or some other data center somewhere else. Whereas if that was in the cloud, I could just go and redeploy those machines in the newer availability zone or the newer region.
Yeah, and even when we talk about like moving to newer compute types, it's not I need to rebuy everything to optimize for ARM. It's I change a config setting and then an entire fleet of applications can now be moved to more efficient hardware.
Just because, like, you know, we're not at the scale doesn't mean that we shouldn't try, right? Like, realistically, I could probably turn off one of my giant rack-mounted computers and, like, move some of those VMs to other machines and better utilize what I already have, right? And then replace those with more efficient things as they come along. And there's not exactly millions and millions of us self-hosters out there, but I think we do have an impact, and it is our responsibility to try to make the most of what we have.
I think every little helps, and do your best. It's impossibly hard.
It does go back a bit to that scale point, though, doesn't it? It is, if it's something where you're big enough that it can be someone's job to try and figure these things out, that does make it a little bit easier. But even at that scale, you say you can redeploy everything on this newer hardware. That new hardware hasn't just disappeared because you're in the cloud. It's somewhere out there, there's a bunch of x86 boxes that used to be running your workloads.
Yeah, they're in my closet.
Well, now that I know that you do in fact all love the planet, it's probably time to wrap things up. Before we do that, thank you to those people who support us on PayPal or Patreon. If you'd like to join those people, you can at hybridcloudshow.com/support, where for various amounts on Patreon, you can get an ad-free feed of either just this show or all the Late Night Linux family shows. And sometimes you receive episodes early. If you have any questions or any feedback, you can send those in to us at show@hybridcloudshow.com, and we'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.